In this lecture of the series Soil, Slopes, and Streams, we'll talk about Hillslope Form. We'll focus on terms we use to describe hill slopes. Being able to describe their form is really important for understanding why they look the way they do and what kind of processes are active in shaping and sculpting them. On landscapes, such as the ones we see here, form and process are closely related. If we look at this system here, we can define two different domains. One is steep and rocky. The other, in the foreground, is rounded and soil covered. Why do these mountains and hills look so different? What kind of erosion is happening in the different systems and what kind of processes? Before we can tackle these questions, there are a few terms we need to master to be able to describe them. Let's start by describing the mountains in the back. First, how high are the mountains? This is measured as the altitude or elevation of the peak. Here, the peaks lie at an elevation of 12,000 feet. Next, how tall are the mountains? This is called the relief. We need two measurements to calculate this: the upper elevation and the lower elevation. If the mountains extend from 3,000 feet at their base to 12,000 feet at their peaks, then the mountains have 9,000 feet in relief. Slope gradient describes the steepness of a feature. For example, here we have two different slope forms on the mountains. We have upper portions that are low slopes and have low slope gradients, and the lower portions have high gradients or are steep. There's one more word that's useful in describing a system such as this, and that's its curvature. The mountains in the background have long, planar slopes. However, the hills in the foreground are wavy. Their gradients change as we might walk across them. For example, the tops of the hills are convex. Their slopes increase as you walk downhill. A concave form is one where the slope gradient decreases as you move downhill. For example, as you walk into some valleys or at the bottom of some hill slopes. Let's think back to these two different domains, the hills in the foreground and the mountains in the background. If I were to ask my 5-year-old to draw a picture of a mountain and a picture of a hill, she would intuitively draw something similar to the sketch on the right without prompting, without even knowing the meanings or differences between elevation, relief, gradient, or curvature. However, each of those are really important for being able to distinguish the processes and shapes of these systems. Diversity of form means diversity of process. The shape of a mountain or hill controls what processes are active, and the processes also control the form. What kind of erosion processes happen on these slopes? Well, in the mountains, we likely have landsliding on the steep gradients, rockfall on cliffs, and glacial sculpting at the highest elevations. While in the soil-mantled hills, we have processes that actively erode the soil and produce the soil at the same time. A different lecture will talk about landslide processes on slopes, and so let's focus on the erosional processes that closely relate to the soils, such as we have here. When thinking about whether a landscape has soil at the surface or not, we have to consider the rate of soil erosion and the rate of soil production or weathering. Check out these two landscapes. The balance of weathering, soil production, and erosion controls what we see at the surface. Bedrock is in the left, and soil as we see on the hills to the right. In the left-hand image, the landscape has a greater capability to erode than to weather and produce soil. This results in little to no soil cover and the exposure of bedrock at the surface. Here, slope form is largely controlled by rock properties. One of the best known places to see this in action is the Grand Canyon. Here, the slopes you see at the surface reflect the strength of rock. Weak rocks, such as shales, are more weatherable and erodible, and form low gradient slopes. While you find steep cliffs where there are strong rocks like the Coconino sandstone and the Redwall limestone outcrops, these rocks, which are shown as the steep bands in the image on the right, are more coherent, less weatherable, and less easily eroded. Landscapes such as this are often referred to as weathering limited because sediment transport in them is limited by the ability to first physically and chemically weather and release the grains out of rock. In the other system on the right, we find a landscape with a continuous or near continuous soil mantle. The presence of soil here means that the soil weathering and production can keep up with the pace of erosion or even exceed it. Erosion in this system is often referred to as transport limited. As there's plenty of weathered material, it's available for transportation, it's just not taken away. Here, slope form is controlled by the soil properties, erosion processes, and erosion rates.